What I'm going to do for the next few minutes is I'm going to try and convince you of the premise that harmful discrimination by online algorithms is a serious public policy problem that's emerging now, and that I have a provisional idea about a solution for it, along with a few other researchers, but it is going to be very difficult. So that's my remit for the next about 40 minutes. I'm going to start with a story. I'd like to take you back to the dawn of commercial computing. I don't know if anyone's ever heard of the Sabre System before. It's a pretty geeky thing to know about. Great job, people who raised your hands. So the Sabre System, when it was introduced by American Airlines and built by IBM, it was the largest commercial computer network in existence in the world. And that was in 1961. The story of Sabre goes that the chief executive officer of IBM was on a plane with the CEO of American Airlines, presumably in first class, and they were talking about things. And at the time, IBM technology was used for missile defense and bomber defense systems for the military. And the logistical problems of running a major airline are immense. And so the American Airlines CEO and the IBM CEO said, maybe there's some way we can apply this newfangled computing technology to the problems of airline logistics. At the time, they had these really interesting, actually, reservation centers around the world where your regional reservation center would have things like a pin board where a seat would be reserved by a series of phone calls, and actually acquiring a plane ticket without colliding with another reservation would take somewhere around 3 hours to be sure that you actually had a claim on that seat. So they built this system, the Sabre System. That's an early terminal for it, and it was originally for ticket agents and then expanded to all travel agents, and it allowed people to reserve airline tickets using a computer, which was a big deal. It's actually the same system that is now supporting Travelocity. So if you ever use those sites, it used to say at the bottom, powered by Sabre, but I'm not sure that it did. So the Sabre System, the CEO of American at that time was a controversial figure named Bob Crandall. This talk isn't about price fixing, but it does seem sort of about his character, because he was often in the news for his business daring, and he introduced the Sabre System, and then some of the competitors to American started realizing that when airline reservation agents made reservation requests, some of the system results were a little strange. So you would request a ticket to Budapest, and although there was a cheap ticket with a competitor to American, it was one stop or 0 stops and relatively cheap, the top of the list would be an expensive ticket from American that was, 17 hours and 3 stops. And the competitors noticed this, and they didn't like it, and they brought it to the attention of the United States government. And Crandall was called in to testify before the US Congress about it. And this is what he said. He said, "The preferential display of our flights and the corresponding increase in our market share is the competitive raison d'etre for having created the Sabre System in the first place." In other words, they called him to account because it seemed like he was fiddling with everyone's airline reservations and giving them bad results to make more money. And he said, of course I'm doing that. Why would I have invested all this money in having a computerized reservation systems if I wasn't going to fiddle the results? The Sabre System, in fact, a later biography of Crandall, he started a unit at American Airlines headquarters, and it was called Screen Science. And it was people in this unit were tasked to rearrange the order of ticket results to maximize Americans' profits with the system. This later became a famous antitrust case in the United States against American that was not particularly successful in antitrust terms. But it's a great introduction because it's the first commercial application of computing, and we find the person behind that saying, you should expect it to be rigged. So if this is the first commercial application of widespread computing, and we should expect it to be rigged, what about today? So the Crandall's system relied on an algorithm, and an algorithm is, in simple terms, simply a step-by-step procedure for accomplishing something. A recipe is a synonym for an algorithm. There is a more technical computer science definition, but we don't really need it for this talk, so we're not going to use it. So in Crandall's case, the algorithm was the thing that produced the list of results. So there was a step-by-step procedure when you said, I want to fly to Budapest from Paris, there was a procedure that produced the results, and he had rigged the algorithm in order to make more money. And this leads me to my first premise of the talk is what I'm calling Crandall's axiom, and that's there's no reason to assume that a given algorithm is acting in your best interest, and that's the topic of the rest of the talk. Crandall says we should be suspicious, and so where would we get if we were suspicious? This talk is a part of a growing chorus of research about algorithms. The phrase algorithmic culture was coined a few years ago by Alex Galloway to describe the fact that most of our online experiences, or even offline experiences mediated by computers, are now governed by algorithms, whereas before we had famous television executives deciding what we would watch. Now we often have algorithms, and whereas before we had shopkeepers, now we have algorithms. Of course, there are people behind the algorithms. The algorithms are written by people, so it's not as though people aren't present, but this is an interesting new kind of mediation, and scholars like Tarleton Gillespie have said that it is extremely worrying because there are all kinds of things that you can do with an algorithm that we don't fully understand the implications of, and we don't really know how to study. Gillespie was talking about the Twitter's algorithm for deciding what is a trending topic, and the fact that that's hugely influential in public debate, but no one really knows how it works, and it's secret, and it often produces somewhat paradoxical results. So just to be sure we're all on the same page, I made a list of things that computer scientists often use as examples of algorithms, just so we're all clear with the idea of algorithm. So the first three are fairly straightforward. They're Google PageRank, Facebook EdgeRank, and Amazon Market Basket. So these are all patented procedures. If you'd like to read them, you can. They're in Google patents. And Google PageRank was the first way that Google produced search results given a query. Facebook EdgeRank is an old way that Facebook used to produce the news feed. It doesn't do that anymore, but it's an old way that it used to do that. And Amazon Market Basket is the patent that produced that line that says, customers who bought blank also bought. And so that's the algorithm that produces that result. But generally, algorithms are very broad. So you could say the secret formula for Coca-Cola is an algorithm. I mean, it's a recipe, right? It's kept in a safe in Atlanta, and only 2 employees are supposed to know it at any given time, 2 in case one of them dies. An interesting thing about it is that it's secret, right? I mean, the first 3 are protected by intellectual property laws, but the fourth one is a trade secret, and companies guard these jealously, and Facebook doesn't want you to know what the algorithm is, and neither does Google. They see it as their main competitive advantage against their other companies. But computer scientists also have these other examples of algorithms, the directions on a shampoo bottle. Does anybody ever read the directions on a shampoo bottle? It's lather, rinse, repeat. So that's a great example, right? Because obviously there are many algorithms for washing your hair, right? Lather, rinse, repeat. And I think that the shampoo company wanted to add that last word, right? Because I personally never do it. I just do the first 2, but I guess they want to use more shampoo. So they optimize for using a lot of shampoo, and they suggest that you might want to use shampoo twice every time you wash your hair. I had a vegan roommate who was really kind of an earthy, crunchy kind of guy, and he had a different algorithm for washing his hair. I'm not exactly sure what it was, but it was much less frequent. And that's the point about algorithms, is that they can be optimized for a number of things, right? We can imagine one optimized for cleanliness, for economy, maybe for saving the earth. We used to put those buckets in our shower so that when you shower, the extra water runs off your body into the buckets and use it to water your plants because it's gray water and it's good for the earth. No one knows what I'm talking about. Sorry, you did it. But also algorithms are things like a mathematical function. Originally in computer science there was a debate about whether we needed the word algorithm because we already had mathematical functions, and aren't they the same thing? The rules that operate a traffic light could be an algorithm, so it's not just sorting results. It could be rules that operate traffic lights. A GPS would be another example of an algorithm. So my argument that I made in the first slide was that there is a harmful discrimination going on in algorithms, and this is an emerging public policy problem. So to make that case a little more specific, to make that case a little more specific, I want to talk about a few problems with algorithms. One of the problems with them is that, as computer scientist Manfred Roy said about software, they're almost intangible. Because an algorithm is, since it's a recipe, it's not really a computer program. It's more like the strategy behind the computer program, and the companies want to keep them secret, right? But even if they didn't want to keep them secret, they're still kind of almost intangible because they're written, when they're expressed as programs, they're written as computer code that's actually quite elaborate. And so it's not exactly clear how you get into what an algorithm is doing, as we'll see in a moment. So let me go over 6 recent problems that have emerged with algorithms to make the case that harmful discrimination in online algorithms is an emerging and significant problem. And these range from about 2 years ago to just about a few weeks ago. The first of the 6 is an interesting investigative report by a reporter that I very much admire named Julia Angwin from the Wall Street Journal. And this is an investigative report where Julia found that during the presidential election of 2012 in the United States, if you searched for the word Obama and then you searched for some other words, you got additional information about Obama's political views. Whereas if you searched for his competitor, Romney, and then you searched for these other words, you did not get any additional information. So some people noticed this just using Google, and they talked to Julia about it, and they said, why is this happening? It seems like a giant incumbency advantage for Obama, because all of this extra information about his political opinions seems to appear in search results after you search for the word Obama, whereas if you just search for things by themselves, it doesn't appear. So for example, if I search for guns, I would get no information about Obama. But if I searched for Obama, and then a few minutes later I searched for guns, I would get all this extra information about Obama, but it wouldn't work for Romney. In this case, it was simply that Google was using a machine learning algorithm to decide on what results to return, and it had trained that algorithm before the election, and the kind of people who search for certain combinations of words when there isn't an election probably have a different purpose in mind than people who are actually trying to decide how to vote. And so, since they used training data before the election, there's no way that it would have picked up anything similar for Romney because those positions didn't exist. And it's quite a substantial advantage for Obama in these results. So this isn't per se illegal, but it's certainly worrying, and it affects how we think about elections and how we think about public information. But now let's get on to stuff that's more illegal. Here's another great example. This is a fun one. This is example number 2 out of 6. This is Harvard professor LaTanya Sweeney. She found that when she searched for her own name on Google, she often got these results that perhaps some of you have seen, where your advertisements appear in the right that suggest that you would like to do a public records check. So it used to be when you search for a person's name on Google, you get these, why don't you do a public records check for this person's name? So LaTanya Sweeney found that when she searched for her name, it would usually suggest that she had been arrested at some time in the past. Whereas when she searched for other people's names, it wouldn't suggest that that person had been arrested. And then she constructed an interesting study where she tested all of the names, or a subset of the names in the US Census, and found that in the United States, African American names were likely to produce this suggestion that the person had been arrested. So that's probably, it's potentially illegal under some of the laws of the United States, but even if it's not illegal, it's a really bad idea for Google. But again, in this case, we see machine learning algorithms. Probably what had happened is that if an ad buyer had done this, it wouldn't have happened. Like in 2014, an ad buyer wouldn't have targeted ads this way, because it could be illegal, and it would be a terrible PR disaster if it was discovered. However, the algorithm didn't know that, and the algorithm used a machine learning process to discover that the users of Google were more likely to click on ads for arrested with an African American name as input. And so what they did is they basically picked up the sort of, you could say, racist assumptions of Google users and magnified them through the algorithm process to in a potentially reinforcing way. So, I mean, there you have a problem of civil rights and racial discrimination. And again, it was unintentional. So it's not about the intent of Google, right? They're trying to do a good job, I hope. The third example out of 6 is from Read Write, which is a magazine. And this is, they released a story about what's sometimes been called like recycling. So it's like recycling. So you know Facebook likes. And so like recycling is the process by which Facebook decides how likes are shared around. It can also refer to fraud in Facebook likes, but you know when you see something on Facebook, you have the option to click like. One of the interesting things about that is that Facebook's rules for likes aren't really the way that you or I would think of likes. And that's pretty much the norm for Facebook. I don't think your definition of Facebook friends is really your definition of friends. So it's an artificial construction that Facebook made up. But their way of doing likes is that if you have an article attached to a status update, say in this case, I got a new car, and you put a link to a web page that describes the car. If someone clicks like on that article, Facebook stems the URL that was attached to it. So they look at the domain name. So in this case, perhaps Subaru.com. And then you're considered to have liked anything that happens in future from that domain name. So, for example, if you, in another example from this article, if you wrote a status update and it says, it's so disgusting that in some parts of Canada you can get a lobster McMuffin at McDonald's, and you have a link to it, and everyone likes your comment because they're like, yeah, that is disgusting. That's really disgusting. They have liked McDonald's, and Facebook sells McDonald's the right to reuse those likes in advertising. So McDonald's pays Facebook to produce ads like this, and when the ads appear, it'll say things like, Phil Howard likes McDonald's. But what he really liked, presumably, was the fact that you didn't like McDonald's. So, so this is an example of, this is also an algorithm where there's no machine learning. It's just a rule that they wrote for how to handle likes, right? Okay, so number 4 out of 6. Yes. Number 4 out of 6 is discovered by economists at Harvard and Edelman, 4 out of 6. That one is actually about Google for keywords. Certain keywords, Ben found, produce different results if you added a comma after the search term. And normally Google doesn't consider punctuation, so it's a little strange that you would get different results if you added a comma. This no longer is true, so it won't work if you're testing it. But what do you see as the difference between these two? Does anybody have something that jumps out at them with the left versus the right?
Ads.
The ads, well, it's interesting that you call them ads, because at the time Google did not call them ads. There was no notice that that was an ad on the left there. But yeah, the first thing up here, it has a little box, it has a little picture, it looks different from the other things. And it's not exactly an ad. I don't think the Mayo Clinic, I can't quite read. I don't think the Mayo Clinic paid for that. But Google Health is always the one that comes up to the left. And so what Google was doing was, for certain keywords, it was producing a new first search result that would direct you to Google properties related to those keywords that were usually just launching. So to help get them off the ground, they would get the top search result for a variety of keywords. And Edelman's interpretation of this is that someone had written the algorithm poorly. So they had written the algorithm so sloppily that they probably had a statement in there like, if the keyword is from this list, then be sure to put Google properties at the top. But the algorithm, as written, didn't recognize the comma, or it thought of it as a different word, so it forgot to do the insertion. So this would be the natural or otherwise results without that item. At least that's his speculation about it. This is serious. So the Facebook example had consumer protection implications and fraud implications and truth in advertising implications. This one has serious antitrust implications. Like, you might not care, right, which website you go to. If you need to define acne by going to a website, like, it's not probably going to matter that much whether you get the definition of the Mayo Clinic from Google Health. They're all going to be equivalent, right? But this really helps Google get its new services off the ground, and it makes it very difficult to compete in the search industry. So even though there's not an individual harm, like you're getting bad results, there's a collective harm because new entrants into these areas are at a disadvantage because they're not Google. So it's serious antitrust concerns for that. This one just broke a couple weeks ago. Maybe some of you saw it in the news, but some computer scientists led by Christo Wilson found this really remarkably prevalent price discrimination strategies in a variety of websites, most notably travel websites. And the price discrimination strategies were interesting. Like, some of them involved discriminating against users of particular platforms. So if you had a certain kind of mobile phone, you would get a different price for hotel rooms. And there have been a number of these. So Amazon, most famously, I think they got the worst press for doing this with Apple users. The Apple users paid slightly more on Amazon for a while. But the interesting thing about this is that it's quite a large difference. So this is it's quite a large difference between the different users. And it's not clear that price discrimination is always a bad idea. Economists tell us it can be efficient, but there are instances in which price discrimination can be illegal, and it raises serious antitrust concerns. One of the interesting things in this case was that people really didn't know that this had been going on. And so it was interesting for that reason. And some of the rules were quite elaborate. Like, for example, one chain of hardware stores would use a location service to determine if you were near a competing chain of hardware stores. and then it would lower your prices, thinking that you had other options. So, which is kind of weird, because if you're ordering online, presumably you could just have it shipped to your house, right? So it shouldn't matter that much, but anyway, that's what they were doing. And the final example is one that you may be familiar with. Facebook was roundly criticized for what's been termed the emotional manipulation study, or it's actually called the emotional contagion study, in which they manipulated the content of your newsfeed to either suppress positive messages or to suppress negative messages from your friends. So some small number of positive or negative messages were hidden from you, and then your status updates were checked to see if you exhibited some change in how positive or negative you were. And this was done, they said, as psychological research, although they also later called it corporate research. So these are my 6 examples of why algorithms are a problem. I hope I've convinced you of that. Now I'd like to talk about the solution to that problem, and that's the social scientific audit study. You may be familiar with this. If you're not, when I use the term audit, I'm not talking about a financial audit. So that's normally what people think of when you say audit. I'm being audited for my taxes or something, or an accountant is auditing something. But there is a tradition in the social science methods literature of an audit, and an audit in that literature refers to, it started by economists who were testing fair housing laws. And economists testing fair housing laws in the 1970s, what they would do is they would basically try to secure, for example, mortgages or rentals, but they would test the fairness of the process for securing mortgages or rentals by varying something about the request. So in some instances, they even hired actors, and they sent some actors who were black and some actors who were white to try and secure mortgages and to try and get rentals, and then they saw if there was any difference in how these performed. And in fact, there was quite a difference. And that's why in the social science methods literature, the audit study is now described as the gold standard or the most rigorous way in existence to prove certain kinds of harmful discrimination. And it's widely used. An example of an audit study, that you might have heard about was released just a few years ago and got some press coverage this summer. It basically was an audit study in which some researchers, they sent appointment requests to professors. So maybe this hits home for some of you. They sent appointment requests to professors, and they varied the name on the appointment request, although everything else about the request was not varied. And so by associating names with certain nationalities, racial and ethnic groups, they saw variance in how people were treated. And they found, actually, this is what the New York Times called it, professors are prejudiced too. So they actually found that women had a much harder time getting appointments with professors than men, and they found that certain groups of people had a much harder time. The study was conducted in the United States. I believe the hardest group were people with Asian names. They were the least likely to get an appointment, the most likely to have no one answer their email. So the audit study involves testing, where you're testing some process and you're varying something but leaving everything else the same. So it's also done in employment. So you send resumes, for example, and vary the name on the resume but leave the qualifications the same. It's a controversial research method for some people because, as you can see, you are making things up. You have a weird relationship to the people you're studying because you're trying to, in some cases, prove that they're criminals, which is not normally how researchers interact with research participants. So what my collaborators listed here on this slide, this is a collaborative project, and I are interested in is to see if there's a way to get around this problem of the harmful discrimination in algorithms and all these platforms by using the audit methodology. So we've come up with sort of 6 types of audits that we think are useful to try and get around this problem of discriminatory algorithms. Some of them are more loosely derived from the audit methodology, and some of them are more clearly audits. But let's start. So the first way that we might get around this problem is, what if we just got the code? So what if we just got a hold of the algorithm and read it? That seems like a really great idea if you're concerned about algorithms, but it's not. It's a terrible idea. So it's the #1 leading policy proposal on the table today to handle this problem. It's called qualified transparency. Frank Pasquale, my great admirer of Frank, is the proponent of this, and many other people have signed on. The reason it's kind of a bad idea to just look at the code is, if you're more familiar with the software side of this, it's not really clear what the code gets you. So there are some platforms now that have algorithms that are open and you can read them. This is an algorithm from Reddit that defines what is hot. see the hot word at the top. And it's public because they want to release it to everyone. And one of the interesting things about it is that there are regular conversations among programmers, presumably some of them are experts, about what it does and how it works. And the only way that people can resolve these conversations is by creating these fake data sets from Reddit and then running the algorithm on them to see what happens. And so really what we want is a combination of the algorithm and the data. Just the algorithm itself, first of all, they're not that easy to read. Like the Google algorithm is now worked on, it's touched, as they call it, by 150 engineers. And it's modified on a daily or weekly basis. So it's hard to know if even if those engineers had the whole thing, what they would do with it. And if you had it, it's not clear how you would use it. Like, can you use this to explain what happened in this particular time I used the system? Well, it might be very difficult. Like perhaps it uses some sort of machine learning process, or it's using the clustering, or it's using some sort of data reduction. And it's hard to say exactly how it got to where it got. So not a good idea to get the code. The right slide? No, I'm sorry. These are out of order, but now it's fixed. Another way to do it is the lone wolf, and that's what you saw in some of my examples earlier. Like if you're a passionate journalist or you're just someone who spends too much time on Facebook, maybe you can find out one of these problems yourself. Create some fake accounts maybe and just look at the differences, do a lot of searches. Some of those examples I gave came from people just messing around, or motivated investigative journalists, or just users who compare notes with their friends. You know, someone looks over someone else's shoulder and says, why does your Facebook newsfeed look like this? But mine looks like that. So the lone wolf, that's a strategy. The problem with that strategy is some things are just not going to be detectable by individuals because of the fact that they're systemic. And even if you did detect it as an individual, it would be hard to say that you had proven something was happening. Because there are so many variables at play in any particular use of a system like this. If you really wanted to make a case over it and have something done, you would need some more systematic data, which is a great role for social science researchers to become involved in this area. So, all right, now I'm back in there. So, another strategy you might use is ask the users. When I was growing up, there was a magazine that's still in existence. It's called Consumer Reports, and the idea of it was that whenever you would buy a car, there was a chance that you would get a questionnaire in the mail after you owned the car for a certain amount of time, and it would ask you how many problems you had with the car. And then Consumer Reports was a nonprofit organization. They would compile all these results in little booklets and sell them. And so the idea is that I think they use title records, government records, to mail out these mailings about car reliability. So if we had something like this for algorithm reliability, that might actually be very useful. And it might take a similar sort of model. And we do have the beginnings of that, but it's really at its early stages. Another strategy that is an interesting strategy is called a sock puppet strategy. In case you don't know, a sock puppet, that's an internet slang phrase for accounts that are false, but usually accounts that are false to a particular purpose or to a particular end. And so the sock puppet strategy, most recently pursued by something called the X-Ray Project at Columbia, the sock puppet strategy is trying to figure out how the algorithm works by doing something a lot more like reverse engineering. So if we want to know why Facebook recommends these news stories or why YouTube says that these are the videos I should watch, let's make a bunch of fake accounts on YouTube with a computer, and then let's vary the kinds of things that we like, and let's try to infer from the systematic variation why the results differ in the recommendations. And it's quite difficult, but the other problem is, I think you can see there's some ethical problems with it, right? Because presumably YouTube doesn't want you making a bunch of fake accounts and selecting things on the basis of your desire to expose their potentially illegal behavior. So it also violates the computer crime laws in many countries, because typically you will have a stipulation in those laws that says that you have to abide by the terms of service or the terms of use or something like that. And no company is going to want to allow this because it opens them to reverse engineering by their competitors. So this has some problems as well. I'm not sure exactly how the X-Ray Project got around that. Two more proposals. Another proposal is an interesting way to think about it is scrape everything. This is from a somewhat obscure painting called The Floor Cleaners. Scrape everything. This is just saying, well, if we're restricted to public information, what if we could find out a lot by public information? Some services expose a lot of public information. So scraping, which is often a word that is used to indicate collecting large amounts of public information from the web. What if we collected large amounts of public information and tried to use that to reverse engineer? It wouldn't be as good as if we had fake accounts in there and we were varying things, but it still might be very valuable. So the scrape everything approach was done recently by journalists who were trying to understand Netflix's recommendation algorithm, and there was a really interesting article about that where they basically found that there was a way you could look at Netflix's public website and see every genre of movie they had ever defined. And so that was interesting because many of them were fiendishly specific, you know, movies set in Budapest with a strong male lead who is a dashing visiting professor giving a lecture at CEU. And you thought, how many movies could there be? But the idea was that this public information might give you some insight into the algorithm, even though it might not be very much insight. So that's a little tricky because you still could have terms of service that would forbid you from gathering large amounts of information, but there might be ways around that. So. Finally, you always save the best proposal for last. And so the last proposal I'll make, and it's the one that we're most excited about, my collaborators and I, we're calling a collaborative audit, and it's based on the experience of websites like Bidding for Travel. So Bidding for Travel, I don't recommend you go to it now, it's changed a lot in the last few months, but Bidding for Travel at its heyday was a web forum where people who were interested in going to websites that use auctions for travel could compare notes. So an example would be Priceline, which uses auctions for travel. It asks you to say how much you'd be willing to pay for a hotel room at a certain date. And so what these users did is they just got together and told each other what they paid and whether they won the auction or not. And they made a larger and larger list of about it. They were trying to share the information that they had. They had gained that information legitimately as using the site in the way that it was intended to be used. So there's no terms of service problem. But then they were building with other users some collective intelligence about how to win the auctions and how to get the best price. They got sued anyway, I think, but still, I think it's a really exciting and valuable way to think about looking inside these algorithms. And the transaction is this. It's that you, as a user, might have an interest in finding out how Facebook's algorithm is working for you. And so maybe there's some way that you can trade what you know about your piece of it to a collective that will tell you something about yourself and combine your information with other information. It might even be the case that you could convince these people to do experiments. Maybe not for hotel rooms, but in Facebook you might say like, hey, do you want to be one of our collaborative audit heroes this week? And try to add the word congratulations to all of your status updates and see if they're featured more regularly on your friends feed. By the way, that has been found to be one of the lines in the algorithm. If you write the word congratulations, your status update is more likely to feature. So for my concluding few minutes, what I'd like to do is talk about one beginning attempt at a collaborative audit, and it didn't actually get to the collaborative audit stage. It's sort of a work in process. It's a completed research study, but we'd like to develop it into a collaborative audit. And so this study, these are the collaborators involved in it. This study is called FeedViz. It's not available online, so if you search for FeedViz, you actually find something else that has nothing to do with this, so don't be confused by that. So basically, we were inspired by everything I've said up to this point, and we gathered together some people, including machine learning expert, applied mathematician, computer scientist, as well as a designer. I'm a social scientist, and we said, how can we tackle this problem of reverse engineering, but not really reverse engineering, auditing these opaque platforms? And we decided to try and learn more about the Facebook news feed. This was before some of the shocking revelations about the manipulation, but still we were very interested in it because of its major normative implications for how people learn about their family and friends and important news. So what we did with the FeedViz study is that we brought a diverse group of 40 people into a lab in the United States, in a university laboratory in the United States, and we gave them a demographic questionnaire, and then we created a Facebook app that would basically use the Facebook API to obtain information about their newsfeed and their friend network that would be very difficult for them to obtain on their own because it's just not the way that information is organized. So we're not using secret information, we're just using information that would be very difficult for them to obtain on their own. And we use the API to query the Facebook to create that information. So we allow them to use this app that we built to explore visualizations of their newsfeed. And then we conduct a qualitative, open-ended interview with them about that experience. And then finally, we followed up with them 6 months later. Yeah. So one of the things about this that's fascinating is that we really kind of messed this up already. I'm hoping you're excited about the study at this point, but it initially kind of went sideways on us because our initial intent was that we thought what we were doing is helping users tell us what they thought about the algorithm, and we thought we were going to learn what they wanted. So we had a motivating phrase. We sometimes talked about folk algorithms. So what would be the way you want your news feed presented, as opposed to the way Facebook presents it? We're not interested in marketing research for Facebook. What we're interested in is if there's some systematic bias in the news feed that would be something you wouldn't like, and that would help us, because this is a new area of research, that would help us figure out what we could then test on a larger scale or expand into a larger study. However, our result was right away that the majority of our interlocutors were not aware that Facebook filtered the news feed at all. So this was about 62% of the 40 were not aware that the newsfeed was filtered at all. And this was a study conducted before the Facebook emotional contagion study, but it still was surprising to us. It was a diverse sample, but there were a couple people that were, there was at least one person who was a computer scientist, and they just didn't ever think about it. They just assumed that if your friend posted something, then it would appear on your newsfeed. I mean, that's how Twitter works for now, and so they thought that that was how Facebook worked. And so we thought we were going to get what they thought about the algorithm, but they honestly hadn't thought about that much before. So let me show you some screenshots of our software. This is the FeedViz software. So it has 4 screens. I'm going to go through it relatively quickly, but I'm happy to take additional questions. So basically what we did is we generated 2 extremely long columns, and I'll separate them with this bar. The left column is everything that they could have seen if Facebook did not filter the newsfeed. So we just queried everyone in their friend network, we looked at what they posted, and then we made a feed for them that would be like a Twitter feed, a chronological list of everything that had been posted. And that's the left column. And then in the right column, we had the things that they had seen. There's a little bit of ambiguity as to whether they had actually seen them or not. It's actually very difficult to pin down, but we're reasonably certain that that's a good measure of whether people were seeing things or not. And then we highlighted things that had been seen in a blue background. And so you see this top one here, happy birthday, was not seen, although it was posted. So I'm going to scroll down a little bit. So here you see we invited the users to scroll down and look at these feeds, and you see here on the left we have a post with no blue background, and that post, I'll circle it, that post was not seen. And this is my feed. I'm running the software on my own Facebook account. And it's interesting because I would have liked to see that, and it's difficult for me to say exactly why that wasn't on my feed. So it was filtered by Facebook, and it's difficult to say why it was filtered. I usually interact with Keith. We know the Facebook algorithm for public statements that it's weighting things like commenting, past likes. It has some measure of network closeness, so it's looking at how many friends I have in common with the other person. But it's still kind of hard to say, looking at a particular thing, why that wasn't there. And that's kind of the experience that we were hoping to bring out in the study. So we ended up revising the study to initially ask people about what they thought about these algorithms, but then we had to do a series of a script where we told them something about the algorithm and how it worked, because otherwise we found it was too difficult for them to even understand what was going on if they weren't familiar with the filtering. So the FeedViz had a series of other screens that, for purposes of time, I'm just going to highlight extremely briefly. It had another screen that we had. It was a series of bar graphs that showed people, friends that posted a lot, that were filtered out by Facebook or that were included by Facebook. So in this set of bar graphs, you saw that there are some people over here on the left. Because there's a 0 line and they're below it, it's telling me that that person posted 3 times last week and that none of the posts were seen. So we're trying to help them understand that Facebook has some people that always get through, some people that are filtered sometimes, and some people that never get through. And on some of our participants' screenshots, these were quite dramatic. Like so-and-so has posted 300 times in the last week, and Facebook has filtered all of them. We then had 2 screens that were similar in intent. They asked people to manipulate the previous screens if they had anything they wanted to change. So if in the previous bar graphs there were people shown that did not appear very often, in this screen they could promote them. So they could change these little buttons below each person, and they could say, I would rather have seen this person. And we were trying to get at this idea of what is Facebook doing wrong, or what are the rationales, what are they doing right, and what are the rationales for why people are included or not included. And finally we had, finally we had a screen that showed content, and it asked people to use buttons under content to see if they would include that content if it had been filtered by Facebook. So it's that stuff that they really would like to have included, even though they didn't have included. So it was our first attempt at this, and it was fascinating. I mean, one of the things that was interesting is instead of folk algorithms, we got this really interesting set of folk understandings about Facebook that were farther off than we thought. This quote from an interlocutor says, "My wife also uses Facebook, and she has occasionally asked me if I saw a post by her friend, and I will not have seen it, and I don't know why I didn't see it." We found that a number of people thought that everything on Facebook was there if you just scrolled down. Like they thought that it was their fault whenever they missed anything. It's a different interlocutor, and he's saying, you know, you can't always scroll down so much. You know, it's like my fault that I'm not getting it. One of the other things that was really surprising and actually quite sad, I think, is that people often had these interpretations that we were jokingly calling algorithm attribution errors, is a little social psychology joke, where they would like make the worst possible interpretation of the fact that something was filtered. So if they had posted something to Facebook and it said like, I really like waffles, and then they didn't get any likes or comments, they would interpret that and they would say like, I posted something about waffles, but no one I know liked it. And so I am never going to post about waffles again. This is a referendum on the topic of waffles, and I have lost. So no more posts about waffles are going to go out from me. Which is really surprising behavior. If you don't know that Facebook has a filter, that makes some sense, I guess, right? If you think that everything is shown. But even people who did know Facebook had a filter did see the algorithm as a way of kind of interpreting their friend network's like or dislike of things. Finally, my last quote, my last quote is that when we told people there was filtering on Facebook and they didn't know it, they became really, really angry. And so they said, what the hell, Facebook? Someone said, have you seen the movie The Matrix? So implying that Facebook was The Matrix, I think. Yeah. So our goal with this study, we have a paper coming out, but our goal of this study was really to take this app process and to move it to a collaborative audit. So what we'd like is we'd like the app to be runnable by anyone on Facebook. And the trade is, why don't you sign into this app? We'll tell you some stuff about your own feed. So one of the things I can promise you in this room is that there's probably some people in your friend network that are posting a lot, and that Facebook has totally decided you never want to see them again. And some of them, sometimes they're things like your brother, and then you're really surprised. And you're like, wow, I really want to see that from my brother. I don't know why that was hidden. So our trade would be, we'll tell you stuff about your feed if you'll let us use your data to build this sort of model, a quantitative model of how Facebook's newsfeed works. And so that's our goal. Then Facebook announced that as of April, they're changing their API, and this project will no longer work. And so this illustrates very nicely the challenges in this kind of research. So we'll try to do it really fast in the next few months. So in conclusion, I've done three things. I started off by arguing that algorithmic discrimination is a problem. I went through a set of recent studies that found there was a problem in it. I talked about the ways that we might solve the problem with auditing, and then I talked about one attempt at auditing that we had started and some of the pitfalls and things that we discovered. But I think the broader conclusions for this are a few things. One is that it's really important that someone is working on a kind of right to look back for these systems. It's just normatively really important because it doesn't make a lot of sense that there are huge social implications and illegality even produced by these systems, and we have no way to check or even see what's going on. So just treating them as proprietary secrets does not seem like a great strategy. Also, transparency and literacy alone are not probably going to do enough because transparency doesn't seem to be able to capture how the algorithm actually works. And literacy is hard to do if you don't know what the algorithm does. It's also not clear it's a great strategy, which I'd be happy to talk about more in the question and answers. We propose this solution of the collaborative audit, and it implies a kind of future auditing infrastructure where you have social scientists who know how to at least make defensible claims about something actually happening, that are systematically looking at, kind of watchdog. Could be located in government, could be located in university, could be an NGO, but something that's checking these algorithms that are now pervasive through our life and being sure that we're not being discriminated against. So, and there's some citations to read more about this topic. Thank you very much for your time. Yes?
What has Facebook's response to your research been?
Well, I mean, the last time
They changed their API, that's what happened.
No, I don't think they changed their API. Had anything to do with us. I don't think they're that concerned about our research. And to be fair, I mean, this was very exploratory research, and you could argue it was very pro-Facebook, because what we ended up finding is that people really hated the fact that there was an algorithm when they didn't know about it. But that once they did know about it, they really enjoyed changing their Facebook activity in order to correspond with how they thought the algorithm worked. And then they were very satisfied with the algorithm. So in effect, the argument for Facebook is tell people about the algorithm, give them more options. And that is the way that Facebook is moving. There's a million more options that allow you to customize the algorithm now. You've got the close friends button, you've got the don't show me this again, and all of these are feeds into the algorithm to help them. That's not going to help. That's going to help your subjective experience of the algorithm, but not necessarily some of the societal harms that I started with at the beginning. I don't think Facebook thinks that we're that big a fish here, although I know that some of the researchers at Facebook have read this study. I haven't received detailed feedback from them. You were next. Yes, Professor Sandvig.
Making sure, Professor Sandvig. So, I love this. I was expecting to hear an audit study. And what I heard instead was a photo elicitation study, essentially. I mean, in essence, with the visualization feed, you're using photo elicitation methods for the 21st century, right? A series of...
Or a cultural probe would also be another way to think about
right?
it, yeah.
But we don't have a language for talking about exactly what you've done, which is almost a social media elicitation, right? That you're giving the subject something to feed back on and reflect. And I just want to make a comment that I love that that work is happening before you build the audit tool.
Yeah, and it's worth noting that it really surpassed our expectations for how successful it was. Like at the end of it, we really were convinced that we did not need to pay our participants anymore. We had been paying them.
Yeah.
And one of our major problems was just getting them to stop. Like they really enjoyed scrolling through this picture of their feed and speculating about what Facebook was doing. So much so that our interviews budgeted for a maximum of 1 hour. In several occasions went to 3 hours, and they just really liked it. So this leads into our idea of making this more widely available with a more intuitive user interface for a future audit.
Right.
I think you had your hand next.
Yeah, well, Facebook just rolled out a new update a week ago or so.
Yeah.
It allows you full customization of your newsfeed, like all pages, all people, whatever you want to see or not.
Right.
How will that affect the study? Because now you're effectively given full control of the algorithm.
Well, okay, so you're not giving the user full control of the algorithm. Absolutely not. I mean, so the algorithm has a number of things in it, and Facebook is adding levers, but certainly the overall algorithm is not under the user's control. And there's a number of reasons for that. Like, for example, you could say the overall algorithm is designed to really prioritize likes and comments and interactions, right? And that's significant because personally, when I started using Facebook, I'm going to sound like a fool to you Facebook savvy people, but when I started using Facebook, I selected my friends carefully, and then I wanted to see everything that they did. That's not the way that the vast majority of people use Facebook. In fact, my daughter, is in this Facebook arms race that is now common among all of our adolescents, where they just try to build up huge numbers of friends. Like at high school football teams, the two sides just meet and exchange Facebook information so that they can add to their friend count because they see it as a proxy for popularity. So Facebook likes that because it wants to gather as much data as possible. So the algorithm is designed to elicit more interactions and to have a certain model of friendship that's certainly not under your control if you get like a see more from this person button, right? So it just has an underlying assumption. Also, the way that likes work, like the example I gave earlier, that's under your control in the sense that there's an opt-out. Like the fact that I can click like, and that like can then be resold as an advertisement later. I can opt out, but we know that opt-outs are hugely classed. So we know that people who are likely to manipulate obscure opt-out settings are likely extremely privileged people that are very heavy users and very knowledgeable about the system. So that when we use opt-outs, we're creating a system that can only be modified by some. So, so anyway, I think that it's great that Facebook gives us more control. It's not total control. There's still a lot that we don't have control over. These systems, I think, are useful in part because they may be used to measure things that you can't measure. So the Facebook tools help you be more satisfied with your newsfeed. But at the same time, if there is some, for example, like the Tanya Sweeney article, if there is some pervasive racial discrimination or price discrimination, that's going to be detected by our audit design, but it's not really addressed by the Facebook little pull-down menus, right? So, and there was 2 more hands, but
This was really interesting. I was just really interested in your opinion on, there's this little new direction in social science research where they actually repurpose this kind of outputs that these algorithms give. So for example, like you would look at the Google search results page and say that since they have the sort of data that any social scientist would kill to have, and they're actually repurposing it. So they're repurposing the Google search results as a tool in social science by saying like, okay, so when we search for something and we get results, we have this assumption that Google is using all the knowledge that they have in order to give us the best possible results that fits our kind of demographics, etc., so that we can learn from these results. So this is basically running a social science survey. And there are like these things where I don't know, you search for something like the separation wall versus fence or the Israeli-Palestine thing, and you get completely different results. And this is, teaching you about how different people use the terms, etc.
I know Richard Rogers is working in this area.
Exactly.
Is that the work you're referring to?
That's one.
Yeah, I mean, and like a great example of that is he got Confederates to search for human rights in every country in the world, and then he compiled the list, and he saw that there were very different top human rights in different countries. I wonder what Hungary is. I don't know. I didn't check. But the Netherlands, where he's based, had some very different human rights than the United States, I noticed. The challenge, though, is that, I think he is completely open about the fact that he's being up for garbage. Like, he is not doing, he's not going to be able to take that kind of approach and file an antitrust complaint or something like that. I mean, maybe he could begin the process of something if he found something, but so I think the goal of audits that would be useful is to try and see if we could get some sort of rigorous way. We can't reverse engineer these algorithms because it's just too difficult, but at least we can have some sort of reliable, systematic study that says, yeah, I think this is going on, it's a problem. And that's really been a problem for journalists because they have done a number of investigative reports of algorithms where they just didn't know what they were doing. And they found that when they searched on one thing and they searched on a different thing, it came up differently, and then they published an article and they got these responses that were like, well, actually, that's because of this totally innocuous thing that we didn't think of. And since you didn't check with us first, and you don't understand how these things work, so we want to avoid that kind of problem. I think.
From a public policy perspective, moving forward into the future, it seems like, what's set up is an algorithmic cat and mouse game. That it's always going to change, and there's always going to be a new algorithm, and it's always going to be tweaked. What do you think the potential is for a push towards, algorithmic awareness? Like, people are concerned about their privacy, and they're to train people about algorithms,
right.
Or to do something like encouraging or mandating that websites need to reveal their algorithms the same way they would reveal their cookie that they're doing tracking of.
Well, I had this slide about the transparency argument, so I don't think that would work. We don't care about their algorithms. It's not going to help us. They could reveal them, but we wouldn't be able to read them.
I'm not talking about the actual code of the algorithms. I'm talking about, I guess, something more. Disclaimer, more in common English.
Well, our research found that in telling people how your algorithm works does tend to benefit you as a company. The place where that's not going to be the case is where your algorithm acts against the interest of your user. And there's a number of places where that happens, and I can't imagine companies talking about it. So for example, if you want to learn how Google works, there's a cartoon you can watch. It's called How Search Works. Interesting, it does not mention advertising, right? So Google's business model is based on advertising. It's like 96% of their revenue it's not mentioned, right? So we're not going to necessarily be able to trust what the companies
Right,
tell us about that.
So in the US, for example, we have the FTC, which doesn't have as much teeth as it should. But I mean, that is a form of deceptive advertising, is it not? I mean, many of the algorithms that you talked, or the examples that you pointed towards. So I mean, is that an avenue?
Not necessarily. I mean, the FTC has done some great work in this area. So we have now, most major internet platforms have consent decrees with the United States because they were threatened with lawsuits about being, about false advertising, about misuse of privacy data, about a variety of things. But I think so, taking your question as a whole and going back to your original point, you premised that this was an interesting cat and mouse game. So I think that's a great way to think about it, actually, because that's capitalism. So we know that there are these companies and they want to make money and they might stray over the line. I mean, that's public interest regulation. I mean, so what we have now is like a cat and mouse game where the government's not playing, or because they're not that familiar with this as a problem area. And so I think what we need is some sort of infrastructure, and it could be based at a government agency, although it seems unlikely, or it could be supported by NGOs, something like that, that's looking for these problems. And it could be something that we all do together. I mean, Consumer Reports was originally a collective of consumers, I understand. It all got together to do that, and so we could do that. So that's more what I'm arguing, and I think that's a really important way to go. But you're right, it will be an indefinite cat and mouse game that we will then engage in, because that's the politics of regulation. So I lost track of hands. In the back, I think. Yes?
Thank you. I just saw a presentation about a study that was conducted about algorithms, and it was concerned about the political implications, namely and mostly about access to information. That is one of the main concerns about algorithms. And what they did, partly, it was just part of the study, it was an experiment. They were showing users, I don't know if you're familiar with the study, they were showing users a little kind of an icon that, that signaled when they went too much to a one-sided consumption. So when they consumed a lot of right-wing articles, they clicked on right-wing articles, then it was showing that they were further and further on the extreme. And apparently users reacted in a very sensitive way. So when they realized that they were getting biased, not that they were getting biased information, they were getting one-sided information, then they got very sensitive to that, and they were trying to get back to the center or consume information from both sides.
They were not Hungarians, right?
They were not Hungarians. And of course, this raises a lot of issues with, you know, how you code for left-wing and right-wing, and it's a simplistic view, so that's not what I'm getting at. But I wonder if you found something similar and what you think of this when you were showing the different news feeds, the real and
well, I think
potential.
There's 2 points there. That's a great thing to bring up, and I think the first point that's worth mentioning about that is that you know, a lot of the coverage on this kind of thing has been framed as a filter bubble, using a research term, and there were no filter bubble examples in this talk. And the reason is I think that we've really been over-focused on that problem of sometimes called excessive personalization. Because in this case, what we have really is, in some cases, far more serious problems. Like these excessive personalization in search results for political issues, it's like, well, maybe the electorate will become polarized in the next 10 years. And you know, some of my best friends are political scientists, I care about that, but that's really different than you just lost $150 on a hotel room right now, or you know, you're paying a price penalty of about 13% because you used a black profile picture on Airbnb. I mean, these are, in some ways, they seem much more urgent to me than the filter bubble issues, although I do care, obviously, about an informed electorate. I don't want to minimize that. So I think the goal of this work is really to try and move the conversation to other kinds of harm. Not to say that that harm doesn't happen, but that there's this other harm that hasn't been getting much attention, and that's really quite important. As to whether we saw that in our interviews, one of the things that we found actually is that people did not largely comment on the political leanings of the people or the posts that they blocked. I mean, in fact, the reason that people were happy or unhappy with posts or people is that they were often unhappy because they didn't seem to be using Facebook the way that the user felt Facebook ought to be used. So usually it was a frequency complaint, too much. Sometimes it was the wrong language, something like that. Sometimes it was like too boring, but not necessarily too Republican. We didn't actually see that come up. We did see this interesting finding that I didn't mention before, that people were really ready to defend people on the basis of families ties. So when they saw that their brother or cousin or in-law had been censored by Facebook, they really thought that was a mistake, because they thought a family member should be included by Facebook, and they were really, they would often comment on that. But remember, we had these different screens, so when they got to the actual content, they would then not select any content from that person that they wanted. So it's interesting whether you define this as a relational thing about your role versus here's what I'm actually posting, you get very different answers. So they all seem to think, Uncle Joe should definitely be on my feed because he's my uncle, and then they read what he's posting and they're like, oh, he shouldn't be on my feed. There was another, but they handed it down.
So you said towards the end that you're going to try to run the study before April.
Yeah.
Can you say a bit about why you want to do that? It sounds like there's going to come a time in May where they'll be able to do whatever they start, and then they'll be able to change the algorithm in any way they want, or the way to audit them.
Well, there'll be no algorithm in this technique that we're using. Yeah.
Do you have a sense of what you might find that's different from your study of 40 people?
Yeah, I mean, in the study for 40 people, Professor Neff was right. It was like a photo elicitation or a cultural probe, because we got how they think about it and what they want, which is what we wanted. But an audit itself, what we would want to do is set a particular goal for discrimination that we want to detect.
Yeah.
You know, and we bring in the machine learning people to machine learning with the quantitative data. And it's true, the data will be multidimensional. It will be difficult to say exactly what is causing what. But so some of the things that we're interested in are particularly the way that links circulate in status updates, because there's a research literature that I didn't go into today about how people are now learning news from Facebook. And so we're particularly interested in the way that the newsfeed algorithm might condition that process with biases that are very difficult for the individual to detect, but we can detect if we did it at scale with a large number of people. And you know, there's even basic things that others have pointed out, like the fact that Facebook's construction of the status update box, you know, with the like button, makes it difficult to share news about genocide, because it's just not really something you want to click like on, because what would that mean? And so those posts don't get likes. Facebook algorithm weights likes extremely heavily, so those posts don't get circulated. And so we're interested in finding a bunch of instances where we think there is normatively problematic discrimination of some kind. Discrimination in the broad sense, not in the sense of racial discrimination, but in distinguishing. And then seeing if we can find it in the data. And this study will be helpful because it will tell us sort of what people think they're doing, which we feel like we have more of a sense of now. And there were a lot of surprises, so this was very useful. Does that make sense?
I think so. I'm thinking about what you're saying about genocide, though. What in what you found would help us explain why some social movements go viral and capture the public attention and draw Facebook users into one country but not another country? It sounds like your answer would...
I think we need to do the study at scale to make clearer statements about how we think the newsfeed works, because what we have right now, based on this 40 people, we have a lot of public statements by Facebook, because they do present at technical conferences and they release papers and they say a little bit about how it works. But there are all these weird things that people seem to discover all the time. Like I mentioned earlier, the weighting of the word congratulations. And there's a bunch of special handling rules for birthdays. And there's a bunch of special handling rules for app updates, like updates that are posted from an app and things like that. And so I think that the larger study will definitely find something, but I'm not sure exactly what it is. So what I noticed from this study so far is that we thought we would get more about news, I think, but we didn't. I mean, people, maybe it's because of how Facebook frames everything as friends and their faces, but people like to talk about their newsfeed in terms of personal connection rather than in terms of being informed about my world. So I think that's more the frame that they have for it, because they are reading news stories from Facebook. Other researchers have found that it's a really important source of news and information, but they don't think about it that way. So they think about it as friendship and family, and so that's That's interesting. I'm not sure exactly how it will play out in the larger study, but it does seem significant.
Well, thank you.
Thank you very much.
Thank you for coming. Yeah.